All right, so we're going to evaluate limits using theorems. This is our bridge from the graph perspective to our algebraic perspective. So we have A and C that are real numbers. So the limit of C, where C is a number, they're saying is C. And an example that's not abstract would be the limit of 3 as x approaches 4. And they're saying that that limit will be 3. Limit of C is equal to C. Limit of a number is that number. Limit of 5 as x approaches 7 would be, according to this theorem, 5. Limit of 2/3 as x approaches -1, according to this theorem, is 2/3. So I don't want you to just memorize something. I want you to understand why. So what I've done, and I'm going to do it with the graphical approach because it's easiest to see. This is the function y equals 2. So if I use this graph and I want to do the limit as x approaches, limit at 2 as x approaches, we'll say, and I want to make this anything to highlight the fact that it does not matter what x is approaching. So if I come to -5, as we approach -5 from the left, what is my limit, Kyle? 2. From the right, therefore the limit would be 2. So if I want to do -2, Madeline, as we approach from the left and the right, therefore the limit is still 2. All right, Anthony, if I approach 1 from the left and from 1 from the right, so the limit is still 2. Ashley, if I approach 5 from the left, what's my limit? And from the right, therefore the limit is 2. So no matter what the number is, if I want to do the limit of pi as x approaches 4, what is that going to be? Luke? Pi. All right. This is one of our fundamental ones. Everything comes down to the constant theorem or the next one I'm about to show you. And the next one is called identity theorem. Now notice this is no longer a number. It's a variable now. This is our function. This is the function f of x is equal to x, also known as y equals x. So if we look at this function, I graphed it, by the way, for you. They're saying that if I take the limit of x, where x is to the 1 to the first power, as x approaches a, that it's going to take on whatever x is approaching. If we look at this ordered pair, it's -4, -4. If I look at this ordered pair, it's -2, -2. This ordered pair is 0, 0. This ordered pair is 2, 2. This ordered pair is 4, 4. Why is this called the identity function? This is called the identity function because your x and your y values are the same. So if I want to take the limit of x as x approaches -2, as I approach -2 from the left, my y values are approaching -2. As we approach from the right, the y values are approaching, so this limit would be -2. If I want to do limit as x of x as x approaches 0, as I approach from the left, the y values are approaching, Caitlin? And as we approach from the right, so therefore this would be 0. So if we want to do the limit of x as x approaches 4, as we approach 4 from the left, the limit would be, and from the right, so it will be 4. So our goal is to be able to take you away from the graph so you can't see it. And if I want to do the limit of x as x approaches square root of 2, that's going to be what? Square root of 2. If I want to do the limit of x as x approaches 7, it is 7. And what is this one called? Okay, you're going to justify using theorems. All right, our next one is called scalar theorem. So this is saying if I want to take the limit of some number times a function, I could multiply the function by that number, or I could take the limit of the function and multiply the result or the answer by c. So if I have the limit of, let's say, 1/2 x squared as x approaches 2, This theorem is saying, well, that's the same thing as 1/2 times the limit of x squared as x approaches 2. So what I want to show you is I want to show you that this is right, that this works graphically. By the way, this happens to be the graph of x squared. So if I want to approach 2 from the left, what are my y values approaching from the left, Corinne? And if I approach from the right, they are approaching. So if I want to do this limit right here, what is that limit? We approach from the left, it was 4. We approach from the right, it is 4. What is that then? This limit is 4. All right. Well, what does the 1/2 do to this function when I multiply by it? It makes it skinnier or wider? Wider. So this just happens to be the graph of y equals 1/2 x squared. So now let's do the limit at 2. As we approach 2 from the left and we approach 2 from the right, what are the y values approaching? 2. So this limit is 2. My question is, what's half of 4? So 2 is equal to 2. Does it work? So this is what I expect to see. If I see the limit of 3x as x approaches 5, you are going to have to use these theorems. You're going to pull the 3 out front, and that limit of x as x approaches 5. What did you do to go from here to here? What theorem? Scalar. You will identify this. You will justify. That's what I mean by justifying. All right. So this is a limit theorem. This is one of our basic theorems. What's the limit of x as x approaches 5? Okay. So to go from here to here, this is going to be 3 times 5. What did I just use? What did I just use? What's the limit of x as x approaches 5? 5. What was that called? We just did this one before scalar. It's the identity. So this is how you're going to be doing the homework. I give you a problem. The first thing you're going to do is bring the 3 out by scalar. Then you've got limit of x. Which one is this? That's the identity. That says the limit of x as x approaches 5 is 5. So the answer is 15. Brittany. Okay, because constant would be the limit of 5. This is limit of x. Okay? Good question. And we're going to work with that next. So this is the last one we're going to do today. This is saying, all right, we want to take the limit of 2 functions added together or 2 functions subtracted. And this is saying, well, instead of adding and subtracting the functions, take the limit of the first, take the limit of the second, then add or subtract the results. I do not think that you have enough information to do A24. A24. So there is no homework because I know that I had to get to this theorem.